So here is our question. We have a Gaussian kernel regression with parameter sigma square equal to 1 by 2. So first of all, what is a Gaussian kernel? The Gaussian kernel is given by kxy equals e to the power minus 1 by 2 sigma square times the norm of x minus y squared, right? So this is the Gaussian kernel, right? Gaussian kernel, right? And here it's given that sigma square is 1 by 2, so this would be e to the power minus of norm x minus y squared, right? Okay, and the data set is also given. So the data set given here is of the form 2 by 4, which means each point or each training example in the data set is in R2, right? And there are 4 data points, right? The first data point is 1 0, the second one is 0 1, the third one is 1 1, and so on. Okay, and we are given the corresponding y's as well, right? Then it is given that the weight vector can be written as w equal to x alpha, right? So here the w is nothing but the w which minimizes the loss function, right? So here w is, let me just write it like this. So w is actually the argmin of argmin over, let me write instead of w say v, such that what is to be minimized? The sum of squared errors, right? So over all data points I running from 1 to 4, v transpose xi minus yi squared, right? This is what has been minimized, and that is how we have obtained this w. And it says that it's written as w equal to x times alpha, right? So what does this mean? This means that the weight vector is written as a linear combination of the data points, right? Now without loss of generality, we can actually say, so there is a result, or there is a theorem which says, so let me just write idea 1 is that without loss of generality, the w, or the weight vector lies in the span of the data points, right? That is exactly why we can write w as x into alpha for some alpha. Notice alpha is a member of what? Rn or R4 here, right? Because we have 4 data points, right? Alpha is a member of the R4. Okay. Now there are ways to obtain alpha. So if I write, so we already know what is w, right? From the regression, from minimizing the least squares, we obtain the w to be equal to xx transpose pseudo inverse multiplied by x times y, right? This is the w which minimizes the objective function, right? Or the sum of squared errors, right? Now it is written that it is given that w is nothing but x times alpha, right? Now in this equation, if I multiply it by xx transpose on the left, what do I get? I get xx transpose and then xx transpose pseudo inverse. Remember, this will be the identity matrix, okay? Because anything when multiplied with its pseudo inverse becomes the identity matrix, times xy equal to xx transpose x alpha, right? Now this can be written as xy equals x times x transpose x alpha. Now let me multiply on the left again by x transpose. So I'll get x transpose x times y equals x transpose x whole squared times alpha, right? Now so this is what so instead of x transpose x, so what happens in the kernel regression? In kernel regression, x transpose x is actually replaced by, so this becomes phi x transpose phi x, okay, times y equals again phi x transpose phi x whole squared to alpha. Again, this is exactly what we call to be k, right? So and this is k squared, okay, that's how it works. Now now the question arises, so this is it, right? And from here we can say that alpha is nothing but k inverse of y. Now if the inverse exists, okay, so let me just write a note. If inverse exist, if it does not exist, then there are other methods to compute alpha, right? Okay, now the question arises, so anyway, what is the question? The question is, you have to find the prediction for a new data point, right? Now suppose you have a new data point, right? So let me call that x new. In general, how do you find a prediction for this new data point? The prediction is given by x new transpose w, right? That is the prediction. But this is where, this is in the non-kernel case. This is in the non-kernel case, right? Okay, but let's see what it gives us. So now we know that w is nothing but capital X times alpha, right? And what is capital X? Capital X, the first column of the capital X is the first training example, and so on. The ith column of capital X is the ith training example, right? So this is equal to x transpose into, say for example, say x1, right? X transpose, okay, I should write x new to denote that it is the new data point x1, right? And then you have x new transpose x2 and so on. So this will be a row vector, and that will be multiplied by alpha 1, alpha 2 and so on, alpha n, right? So it's a dot product of two things, right? So I can write this as summation of alpha I, and then I will write x new transpose xi, right? I running from 1 to n, but here I'll write 1 to 4, okay? Now what happens in the case of a kernel method? In the kernel method, so in kernel method or in kernel regression method, what happens? The same thing is the prediction with this minute difference. What is the difference? Instead of phi, so instead of x new transpose xi, we will have phi of x new transpose phi of xi, right? And we know that this phi of x new transpose phi of xi is nothing but kernel of x new comma xi, by definition, right? This is by definition. That is how kernel is defined, right? Definition of k xy, right? Now we are given what k is supposed to be, right? So how do we find the prediction? Okay, so we are given alpha, so given alpha, right? And we are also given k, right? Now how to find the prediction? We have to take dot product of the, so compute the take the k x new comma xi for each data point xi in the training data set, right? In the training data set, and after that dot product it with alpha. That is a strategy, right? So what is our new data point? 1 1, right? So this is x new is what? X new is 1 1. Now what is x? 1 0 0 1 1 1 0 0, right? Capital X is 1 0 0 1 1 1 0 0, right? Now if I take dot product with each of them, so what will be k of x new comma x1, that would be 1. Same thing with x2, that would be 1 again. With x3, uh, so okay, so we have to use the kernel, right? So which is e to the power of minus this one, right? This expression here. This expression is what we have to use instead of the kernel. So we will write e to the power minus of uh, distance square. So this would be e to the power minus 1. This will also be e to the power minus 1. This will be e to the power 0, and with x4 it would be e to the power 2, right? Minus 2, not 2, minus 2. So this is the kernel of x new with x2 and so on. Okay. Now what we have to do? So we have taken the kernel for each of them. Now we have to dot product it with alpha, right? And what is alpha? Alpha is given to be 1.4 minus 1.4, 2 and 0, right? So 1.4 minus 1.4, 2 and 0. Now if we take dot product, we'll get, so this guy, summation alpha I k x new comma xi, I running from 1 to 4, this would be equal to 1.4 e to the power minus 1 minus 1.4 e to the power minus 1, that will get cancelled out, plus 2 into e to the power 0 plus 0 into e to the power minus 2. Now this will be equal to 2. So this is the prediction. Okay, so the prediction is for 1 1 is 2.